So we have started with the unit gravitation, and in this lecture we are going to study what is a global positioning system. So everyone of know this term GPS. Okay, long form is a global positioning system. If you have went in some new city and if you want to search for a very famous shop, you just go to the Google Maps and you search for it. So this is nothing but the GPS systems. Okay, so with the help of this GPS you can track or you can search for that shop. Okay, now today we are going to see what is this GPS systems. Okay, so this GPS system was nearly started in 1978 by this NASA. Okay, and up to now they have launched nearly 777 satellites, and out of which only 32 are working. Initially this project was used only for the military purposes, but nowadays it is open to the all public. Okay, now this what is mean by this GPS system? So this GPS system will consist of many geostationary satellites. Now we know the meaning of the geostationary satellite. Know the meaning of the geostationary satellite, the satellite which is revolving at a height of 36,000 km from the Earth's surface and which is having the time period of the 24 hours, which we call it as a geostationary satellite. Now this GPS systems works on a principle which is called as a trilateration mathematical principle. Okay, I'll write it here. So even though the name looks very complicated, so this principle is very easy. What is meaning of a trilateration? So let us see here. If this is a point and if I want to tell exactly the position of the point, so if I take some another person A is standing from person B from the 5 centimeters, this data is not sufficient because see here the point at a 5 centimeters could be here also, it could be here also, it could be here also. So you can draw a circle of 5 centimeters and that person A could be anywhere in this on the perimeter of this circle. Now if I take some another point, okay, and if I call this as a point C, and if I'm telling you that there is a person who is 4 centimeter away from the A, then also we can draw a point like this. So there is a probability of finding this person A anywhere in this region now. Okay, so this could be the region now. Now if I give some another point, if I call this as a D, and if I'm telling that the person A is standing from 7 centimeters from this person A, then this is 7 centimeter. So this 7 centimeter I can draw a bigger circle of the 7 centimeters like this. Okay, now I could exactly tell the position of A. It means that trilateral, by using 3 reference points, I can find the exactly the position of any person, any object. Okay, so this is called a trilateral mathematical principle. Okay, now if I use more number of circles, more accurate will be the position of the object or the person. That's why this NASA is trying to increase the accuracy by increasing the number of the satellites. Okay. So this is a principle on which this global positioning system is working. Now this GPS systems, the satellite is continuously giving out the signals, and these signals are received by the receivers on the Earth's surface. Okay, and while the signals are being received, there could be different errors in the receiving of the signals. Okay, if the signals received are having some errors, the position will not be exact. Okay, there are different errors now which are observed in this signal which is collected by the receivers on the Earth's surface. So few are due to the ionosphere and the troposphere of the earth. We know that earth's atmosphere is there, okay, and it consists of the different layers called as ionosphere and the troposphere. To the more vibrations, or due to the more movement of the particles inside this ionosphere and the troposphere, the signals which are received, they could give out the errors, okay. So the signals which are given out from the satellites, they could be interrupted due to this ionosphere and the troposphere. Now there are signal multipaths are there. We know that on the earth surface there are many buildings, okay, and the signals which are received from the earth surface, they could hit the buildings, they could be reflected from those, and some errors are created due to the uh, bigger objects which are present on the earth surface, and these are called as the signal multipaths. Clock which is present in the satellite, which is very accurate, we atomic cesium atomic clock is there inside this satellite, but this much accurate clocks are not present in the receiver on the earth surface. So there could be a error due to the inaccuracy in the receiver clock, okay. So the time mismatch could also form the orbital error, which is due to the mismatch between the timings which are sent by the satellite and collected by the receiver.